Let's check out this SSD.
Hello viewers and welcome to Kel Technologies. Technology is brilliant until it stops working for absolutely no reason, and that's where we come in. Okay, so today we'll be taking a look on a couple of SSDs, hard drives, and we try to figure out what exactly are the benefits, the pros, the cons, cost differences, the reliability, and so on. At the end of the day, it will help you better understand what an SSD is, what it can do, and I think most importantly, how to prolong the life of your SSD in a sense that we want to minimize the possibility of failures. So what is an SSD? An SSD is basically a storage media, or more commonly known as a component in your computer that stores all of your information, pictures, documents, your windows. Just for comparison, this is a hard drive, this is a SSD. It weighs lighter, it's faster, more responsive, and in some use cases actually outlast hard drives. This is what's been found for the longest time. We started with 40 GB, 1 terabyte, couple of terabytes these days. So, well, a hard drive essentially consists of a spinning platter. This spins for end user roughly around 5,400 revolutions a minute, and then we got this little head stack here that slides around like this, trying to read your data. Now, just to share with you, this platter is not a single disk. If you're able to see, there's actually multiple drives, multiple platters stacked one on top of the other. We've got a couple of SSD examples over here. We've got this. We've got couple of ones that look like this, right? We also have ones that look like this, and some even more unique ones that look like this. This is also an SSD. This and say something like this is basically the same thing. It's just different size. So this size is known as 2280 and this will be 2230, and we have a in between. If I'm not mistaken, this is 2240. So they're all the same thing at a glance. It's just different size to fit different needs. I think the most commonly found SSDs today will be the M.2 form factor. Okay, so M.2, it's easy to remember because they just look like a slightly bigger pen drive, thinner of course. Okay, in this M.2 size or form factor, we've got two different protocols. So we see these two, they look the same. But they're quite different. Okay, so this is a SATA M.2. One of the giveaways, or one of the quickest way we can tell, is by looking at this key over here. We see there is two slots, the M and D key. For NVMe's, likely there'll only be one slot, not two. We do have NVMe's that look like SATA. Right, it's got two keys. It's got the M key and the B key, but it is an NVMe. If you plug this into a SATA only connector, it will not work. You can see that your data is essentially stored in these NAND chips over here. This little square thing here, this is basically the controller, and every SSD has a controller. Another thing worth noting is DRAM. Okay, just like how your computer has RAM, SSDs too have RAM. So you can see this is the controller, this is the NAND chips, and this is your DRAM. Since there's no moving parts, everything is a lot more snappier. It's faster. It's got almost zero latency. SSD failures, or how, why, and what causes it to fail. So SSDs, unlike traditional hard drives, they have a finite amount of writes, which means there's a limited amount of data you can write onto it before it eventually wears off and spoils. So to illustrate what I'm trying to say here is, I will use a piece of paper as an example. Okay, this piece of paper represents the NAND chip. These black chips here, these black chips. So when you get your laptop, the first thing you will do would be to install an operating system. May it be Windows, Mac, or Linux. So this is your operating system. So this is the NAND. This amount, roughly this amount, has been used for your operating system, which leaves only this much free space. But that's not it. You also have your own data, which means the actual usable portion on which the drive can write your data to is only this bottom part here. This top part here, you can't. It's already filled with data and it will likely not move. So what happens when you write your data? And also, what is write your data? Write your data could be anything from saving your Word file, your document, or as simple as watching YouTube on a web browser. Let me just use a 4K YouTube video as an example. So I've opened up the YouTube video. Now you can see the YouTube video is buffering. You can see that bit is coming. So where is that bit going? That bit is getting written onto your storage drive. So let's just write that data here. So this squiggly lines is basically your YouTube video. Now you're done watching your YouTube video and you've closed your web browser, and what happens to the data? It gets erased. Or actually not erased, it gets marked so that other data can be written on it. But the point is, it will eventually get erased or replaced. Right? So you got again free space. Now you watch even more videos. Oh, okay. So go on, write more videos, and then you install more programs, you copy over more files, eventually more and more gets used, and then you write, and then you erase, you write, you erase, you write, you erase. Eventually this bit is going to tear, right? So the same thing happens with your NAND chip. This thing gets worn off. Now, the important bit about this is, I want to highlight the fact that you need to keep as much free space as possible, okay, so that you have more free space for your SSD to write its data. So instead of writing on the same area and causing that bit of the chip, that bit of the flash drive to wear out, you can now write this whole area, which significantly prolongs your SSD's life. Another one more type of failure, or common reasons for failure, would be temperature or thermally related. This SSD, okay, slightly different. It's also the same thing. It's got a controller, it's got its NAND chips, it's got a DRAM behind here. But the one that gets most hot during a drive's operation is usually the controller. Right? We've seen controller reach temperatures of 80 over degrees. Now, what happens is when it gets to that temperature, and then you turn off your computer, it cools back down. And you turn it back on, it heat cycles, it gets hot, cold, hot, cold, hot, cold. And eventually, we develop a problem with the solder connection, the solder joint. So behind this controller, it looks something like this. There's a bunch of solder joints known as ball grid array. All that needs to happen is just one of these need to fail. And when it does, this drive becomes unusable. The relationship between thermals and the protocol of your SSD. So based on our experience over here, we've seen PCIe there's three main ones: PCIe 3, PCIe 4, and PCIe 5. The 4 and 5, the controller bit tends to run much hotter than a PCIe 3. This is a PCIe 3. It tends to run much cooler, on average about anywhere from 40 to 60 degrees versus 70 to 90 degrees. So the hotter the drive runs, the shorter the lifespan would be. Another thing I want to highlight, for certain use cases, example, graphics designers, those who do computer fluid dynamics calculation, those with a lot of calculation, work whose software does a lot of calculation. Odds are that software would require a thing called scratch disk, or some people will call it virtual RAM or paging file. So that is really, really bad for SSD, because in order for that software to work, instead of using the actual RAM, it will use your SSD, right? It will just write a whole bunch of data that's required for that software to work, and when you close that software, that data will get wiped off. And every time you use the software, that same process repeats, right? And it's the issue becomes significantly worse if the lesser free space you have. For example, if you open this PC and you see your C drive, it's already red in color, right? Which means everything you're doing in that computer is only getting written to a very, very small portion, hence accelerating its wear. So that's not good. Keep your SSDs as empty as possible. In some cases, you can't do away with it. You need that SSD, and that's your work. So those kind of instances, what we would usually recommend is to pair an SSD with a conventional hard drive. So we can use the hard drive to write all the virtual RAM data, scratch disk, and so on, because this has got infinite amount of writes. When it comes to buying an SSD, we get asked a lot if brand matters. To some extent, yes, but our rule of thumb is if you're looking for a value-based drive, we would just suggest looking up the brand on the internet. And if they are reputable, they have a bit of track record, for the most part, it's okay. And also to share with you, the brands don't really manufacture the drive, as in the NAND chips itself. The brand mostly engineers the drive. So if we take a look at it, this is the A-Data SSD. And if I peel the sticker back, you can see that the controller is manufactured by SMI, the DRAM is by Nanyang, and the actual NAND chip where your data is stored is manufactured by Micron. Okay, same goes with this SSD. This SSD is from a MacBook Pro. The controller is Toshiba, and so is the NAND chips. And if I flip it around, the DRAM is by Micron, right? So one brand of SSD can have multiple component manufacturers, or multiple components from different manufacturers. Western Digital, this is a Western Digital M.2 NVMe. You can see both the controller and the NAND chip is manufactured by SanDisk. Now, instead of focusing on the brand, I would rather suggest you focus on the type of NAND chip. So there's usually 4. If you were to Google it, you will come across 4. You have SLC, MLC, TLC, and QLC. Basically single, multi, triple, and quad layer cells. So for SLC and MLC, we usually don't really bother too much. We focus more on TLC and QLC because that's the one we come across the most for consumer and SSDs. Now, for TLC drive, it's obviously the most superior one compared to QLC. Reason being is because you'll only store 3 bits of data per cell. Now, the benefit of doing that is you have less wear on the NAND chip, you have faster access to your files, and also lower temperatures. So ideally, when you're buying a drive, look for a TLC drive. If you want to dive deeper and get a better SSD, you can then research about the controller that they'll be using. A good controller is important because it will help you. This is the thing that controls the wear leveling and to some extent determine your SSD's lifespan. If you already have a computer that's a couple of years old and you want to know if your SSD is still healthy, if it's okay, or so you feel like your computer is acting a bit weird, softwares are starting not to always coming out as not responding, your Windows Explorer keeps hanging, what you could do is you could do a very simple check, which is to check the SSD's smart data. The smart data is essentially a built-in tool which records the amount of data you've written to it, your temperature, your bats, your reallocated sector counts, and so on. So to access that data, you can use Crystal Disk Mark, or you can run this script on CMD. The thing about smart data is it is not always accurate. Smart data can show you that your drive is 100% healthy, but it can still fail. We've seen cases like that. So when I plug in the drive is now cold, right? It's room temperature. I plug it in, I access the smart data, it shows me as 100% healthy. But when I use it for a few more minutes, especially when I transfer files and so on, the drive will get disconnected, right? It gets disconnected, and then, I restart the computer and it's back in again, and then it gets disconnected. So why does that happen? So that could be a thermal failure. It's a little bit more tricky to pin down on that issue. But if you have such symptoms, even though your smart data is showing you that your drive is perfectly healthy, but your computer still keeps hanging, occasionally when you turn it on, it says no bootable device, or you get random blue screens. At that point in time, you want to bring it over to us, and we will help you to do a detailed scan, stress test, and finally we'll issue you a report to show you the exact condition of your SSD. And based on that, we will make our recommendation if either you need to replace it, or you could continue to use it as a secondary drive, and so on. I hope you gain a thing or two from watching our videos. We plan to do more of this in the future. So in the meantime, do like and subscribe, and hope to catch you soon.